Welcome to Mathcast Edition 6, where we will be using the area model to illustrate the distributive property, again with binomial times binomial. This time we'll be looking at some more difficult problems. So let's get started. Polynomial definitions. If these are unfamiliar to you, you may wish to pause the video now and have a quick read. Monomials are one terms, binomial have two terms, and trinomials have three terms. We'll be spending most of our time today with two terms. Alge-tiles. Positive alge-tiles are represented with blue. Negative alge-tiles are represented with red. To have alge-tiles adjacent to each other, they need to have the same length shared between them. You can see that here, that the x and the x squared term, because they have the same shared length, they can be put next to each other. And the ones, because they do not have the same length with the x squared, cannot be put here, but they could be put next to a next piece. First example, I would like to multiply 3x plus 2 times 2x plus 1. Now you'll notice I have expand written up here as well. Sometimes the textbook instructions are expand, sometimes they're multiply. What we want to keep in mind is that these are the length and the width of a rectangle, so I will illustrate the 2x plus 1 on the left hand side here, 3x plus 2 on the top, so these are my dimensions. When I multiply these together, x times x is x squared. Now I have to repeat that calculation several times, so I'll just bring those all in at once. X times 1 would be just x, and again I have to repeat that calculation several times. On the bottom I have 1 times x, again for more x's, and lastly 1 times 1 for two singles. There they are. When I bring in the algebraic equation side, you might start to see a little pattern developing here, that I have my 6x squareds, there they are in the middle, 3x plus 4x on the bottom and on the sides here for a total of 7x's plus 2. You may also start to see a bit of a shortcut happening where we could take the 3x, multiply it by 2x, 3x times 1, that would be these first two terms, and then taking the 2 times 2x and the 2 times the 1, and there's the last two terms. Let's keep an eye on that shortcut. Alright, example 2. We're going to multiply negative x plus 4 times 2x plus 5. So I'll put negative x plus 4 on the left side, 2x plus 5 on the top. This will be a fairly large array. Negative x times x is negative x squared. I have to do that calculation twice. Negative x times positive 1 is negative x. I have to do that one 5 times. There it is. Positive 1 times x is positive x, and you can see I have a lot to fill in here. And lastly, positive 1 times positive 1 is just positive 1, and I fill in the rest with singles. Again, we have the zero principle canceling off pairs here. So for each negative x you see, it can cancel off one of the positive x's. So when I bring up my algebraic expression here, you can see I have negative 5x plus 8x. When I combine like terms there, I'm left with just positive 3x. If we explore our shortcut again, negative x times 2x, negative 2x squared, negative x times 5, negative 5, 4 times 2x, 8x, and 4 times positive 5, 20. This is sometimes called FOIL, first, outside, inside, last. I prefer to just remember the pattern. Now if you'd like to take a moment here and try this example for yourself, please pause the video, come up with your solution, and then I'll post mine. So here we go. 2x plus 1 on the left side. 2x plus 3 on the top. X times x is x squared, so I have 4 of those. 1 times x. I'm going to repeat that calculation 6 times to fill in the remaining right side. 1 times x for the bottom. I'm going to repeat that twice. And lastly, 1 times 1. I need to repeat that calculation 3 times. And if we check out the algebraic expression, 4x squared, there they are, plus 6x on the right side here, plus 2x on the bottom, plus 3, on the bottom corner here. Again, like terms combined together to give me 8x. If we look at the shortcut, 2x times 2x is 4x squared. 2x times 3, 6x. 1 times 2x is 2x. And 1 times 3 is 3. So the shortcut seems to hold. Thank you for your time. If you have any suggestions, questions, or concerns, please send an email to me at childs_math@yahoo.com. We thank you for your time.